Me. Good morning, everyone. I'm Jeungmin, PhD student from Department of Knowledge Services Engineering in KAIST. I'm really glad to be here to present ScanShot, which automatically deals with erroneous orientation problem when capturing a document using smartphone built-in camera. Courses are the following on the slide. We often take photos of documents in order to digitize our note-taking or memorable parts in books, as in this photo. There are many mobile apps specialized in information capturing, such as Scannable from Evernote or Microsoft recently introduced Microsoft Office Lens. These apps help document capturing with a variety of functions, such as cropping, correcting perspective, or resizing and controlling contrast. Surprisingly, those apps all have critical problem when taking a document. To demonstrate what the problem is, let's take a photo together. Occasionally, photos are taken with erroneous problem as shown in this photo on the slide. On the left side, the photo is the expected result with correct orientation. However, the right side photo is captured with wrong orientation. So you may experience once while using a smartphone. The goal of our research is to solve the erroneous orientation issue when we capturing a document by using a smartphone camera, by understanding the problem in depth. Why does such orientation problem happen? As shown in the slide, there are 4 possible orientation for smartphones unless the app developer restricts the orientation change event. In document capturing situation, the system failed to calculate orientation properly. This is because the orientation is commonly located perpendicular to the direction of gravity while capturing a document. So when we grab phones like this parallel to the ground, the orientation doesn't work. The orientation easily changes to arbitrary orientation mode due to the user's momentary movement or tilt. An experiment with 10 people was conducted to understand severity of the problem and find a solution using built-in sensors. So we hired a National Geographic magazine. We marked 20 parts using sticky notes and let the users to capture the marked area as usual they do in their real life using smartphone camera. We also collected accelerometer and gyroscope data. We used Nexus 5 at the standard Android device. The results show that the error rate for a landscape document is more than 80%, which means the problem is quite severe. It was also consistent among the participants. Note that the lower error rate in the portrait task does not mean that the orientation is captured properly. This is because the default orientation mode is for portrait for Android devices. To solve this problem, we designed ScanShot, which automatically corrects wrong orientation using smartphone built-in sensors. ScanShot consists of 3 parts. So firstly, it detects when the user is capturing documents by detecting document capture moment using accelerometer. Secondly, once the document capture moment is detected, ScanShot updates the erroneous orientation by tracking the rotation. In addition, ScanShot also displays overlay indicator for manual correction in case of failure. I'll explain these steps one by one in detail in the following slides. So this is the first step. So as a first, ScanShot checks gravity force on the z-axis of accelerometer to determine if the user is capturing the documents or not. After a user spots an area to capture through previous screen, the z-axis value approaches to gravity value and the device's movement gets stabilized. I will show you how it works in the video. So in this video, you can find how the document capture mode is detected by ScanShot. If the tilt angle becomes closer to the document, like this, the document capture moment is activated. Internally, ScanShot sliced the sensor value into 2-second window and check whether average and the standard deviation is within certain threshold or not. As a second step, once the document capture moment is detected, ScanShot applies newly calculated orientation to the system. The new orientation is computed by integrating gyroscope value, which contains rotation information. If the integral value is higher or lower than certain threshold, ScanShot changes the orientation. From our user experiment, we set the threshold as 25 degrees. The evaluation showed that ScanShot reduced orientation error significantly by 59 percentage point for landscape documents. Portrait task has similar result, which can be found in the paper. We further improved this accuracy by activating ScanShot ahead of launching the camera. As a final step, we displayed an overlay indicator for manual correction if needed. One interesting finding from our user study was that users are not aware of why this problem happens. So, because the orientation icon is not good for recognize, we use paper metaphor overlay image to help user to easily recognize orientation, and our participants were quite satisfied with those user interfaces. So here is the final implementation. So as you move the phone, it automatically corrects orientation like this. So those are all for my presentation. Thanks for attention. I'll happy to accept any question. Thank you. Thank you.